back to Module 6. The second week of Module 6 is all about polar coordinates. So we're going to start off by converting between rectangular, sometimes called Cartesian, and polar form. I'm going to give you 4 examples to start off with, just from the first page of the task, and then I'll talk to you about the second page of the task. Please come to office hours if you want more solutions. I gave you a heads up that these are tricky, and I mean it. That's why we started them a little bit early. We started them last week, even though we're not going to get into the meat of them this week. So if you have a cool solution or if you have a question, post it to Google Classroom. Let's get the conversation going. I'm going to dive into number 1. Number 1 is asking me to turn this point, -1, 1, into polar form. So I want to remind you, it's the same exact place. It's the same exact place. So if I think of plotting -1, 1, that's where the point is. Well, in polar form, we're changing that into r comma theta. So let's actually draw the radius. In drawing that radius, we now see, hey, look, this is a right triangle we're familiar with. And what are the lengths of the sides of that right triangle? Well, this one's 1, and this one's 1. You can either remember your special right triangles and know that this one is radical 2, or you can just quickly say 1 squared plus 1 squared equals the hypotenuse squared, or 2 equals the hypotenuse squared. So our hypotenuse is radical 2. Cool. All I need to do now is find the angle. And the angle of rotation is right there. So I have some options for this angle of rotation. I like to think of this, well, isn't my tangent just 1? So if I find out where the tangent is 1/1, or just where the tangent is 1, I can have that angle. But this is where I have to remember that we are going in the negative direction. And this helps me give a little bit more detail. I don't just want to know where the tangent is 1. I want to know where it is -1. So hunt your unit circle or think logically about this, and you will find that that is 135 degrees or 3 pi over 4. Either of those would be fine. We're going to go ahead and stick with radians as we go through this. So I am going to use 3 pi over 4. So when writing that polar form, we want to do r comma theta. Our radius is radical 2, and our theta is 3 pi over 4. There are lots of other solutions to this. For example, if I wanted to use the radius of negative radical 2, I could have just used a different angle. If I wanted to use a negative angle, I could have used a negative angle. There are other solutions. This is not the one and only, but there you go. Now let's try the reverse. We just did rectangular to polar. Let's do polar to rectangular. So once again, I'm going to start by just graphing number 4 here. When I graph number 4, I'm thinking about drawing a radius length radical 3 at an angle of pi over 6. Once again, let's put that into a right triangle. We are now looking for the x and y coordinates for that right triangle. Now, if you remember your special right triangles, this can go pretty quickly. This side is 2x, this side would be our x, this side would be our x radical 3. But if that's not something you remember, let's go to something you can do every single time. And that's, let's find our y coordinate by setting up a sine ratio. Sine of pi over 6 equals y over radical 3. We know what the sine of pi over 6 is. It's 1/2. Multiply both sides by radical 3 to isolate the y, and I get that y equals radical 3 over 2. Cool, let's do the same thing with cosine. Cosine of pi over 6 equals x over radical 3. Again, that's just adjacent over hypotenuse. We know what the cosine of pi over 6 is. It's radical 3 over 2. Multiply both sides by radical 3 to isolate the x, and we get 3/2. So there we go. We have our x coordinate, we have our y coordinate. We can go ahead and just write this as a rectangular coordinate now, 3/2, comma, radical 3 over 2. So that's how we take a point between rectangular and polar form. We actually can graph it, visualize where that point is with our right triangle, find the missing sides, the missing angle, whatever we need. But let's dive into an equation, because equations are a little bit different. For equations, I want to highlight, literally, this information we know to be true. We know that x is the same as r cosine theta, y is the same as r sine theta. R equals the square root of x plus the square root of y. That is just the Pythagorean theorem, guys. That is the same as saying the hypotenuse squared equals one side of the triangle squared plus another side of the triangle squared. And I actually like to write it in that form a little bit better. We also have this little detail right here that the theta is the inverse tangent of y over x. You'll find opportunities to use that, but that's one of the least used ones. But keep it there in your toolbox. So when I start these, I'm going to start mainly by using these two right here. X is the cosine and y is the sine. So if I'm looking at number 5 here, well, I know that y is our sine, so I'm going to change this to r sine theta, and x is our cosine, r cosine theta plus 1. And the goal of a polar form is r equals. We want something to be r equals blank. So let's keep manipulating this a little bit. Let's put both of our r's on the same side of the equation. If I subtract 2r cosine theta from both sides, I'm just kind of moving it over to be with the other r. Now that I have both r's on one side, I want to factor that r out. I'm going to shift this over a little bit so I have some room to work. So I'm going to factor that r out, and what I'm left with is sine theta minus 2 cosine theta equals 1. Well, here we go. We can isolate the r fully by dividing both sides by this expression, sine theta minus 2 cosine theta. So r equals 1 all over sine theta minus 2 cosine theta. And I know what you guys are thinking. This does not look any simpler. This does not look clean, nice, easy to read, anything. No, it doesn't. That's okay. There we go. That is how you will convert an equation. I always look to use my r sine theta and my r cosine theta first, because when it's a basic equation like linear, we don't have anything squared, we don't have anything divided. That's going to be generally the first route to go. If I do see something squared right off the bat, I might try to use the r squared equals x squared plus y squared, but I know that I could also use it with these two I just showed you. Again, you're going to find many, many methods to get to the same answer